Thank you for all the other speakers. This is really a fascinating set of talks. And so in my talk, in this short talk, I would like to discuss and share a few insights from my project. It is called Destabilised Common Grounds, and it is a participatory installation and a game based on interaction with moss plants. And I hope this might maybe raise a new idea of how we might approach all these problems that were just discussed as designers. So through this project and research, I'm asking, how may interaction with living moss, plants that respond instantly to their environment, help visualize the relationship between society and ecology? This project deals with the complexity of visualizing soft information about economic and social dynamics and its relation to ecology. An example of this kind of society-ecology relationship is a situation called the tragedy of the commons. So Andreas Weber's quote here is responding to a term coined by the ecologist Garrett Hardin. This is a situation in which people's short-term individual interests are at odds with long-term group interests and the common good. This dynamic can result in the lack of care for the common landscapes, and while resources are being extracted and exhausted. Julie Doyle describes in her book how this is a tremendous challenge to engage the public with environmental stewardship. So even if we know that we are causing harm to the planet, this is still the time for the impacts of our actions to take place and show signs is kind of, it's a different time frame for us. And it's happening remotely in a different geographical area maybe. And anyway, how can we as an individual or as a small group can impact and save the world? We need a collective action to become visible and actionable. So my work is designed to reveal these interconnections through interaction with moss by creating a microcosmic climate map. The moss is an intelligent matter that responds very quickly to its environment and can act as a visual feedback. In this live installation here, visitors influence the climate of moss colonies by spraying water and blowing hot air over it, witnessing the impact of their action in real time through two large projections. And I'll show you how it works. So in this time lapse, this is the moss landscape that I used. This is actually a doormat that I collected from one of my neighbors here who threw it away. And I asked if I can just take it and bring them a new doormat. And some moss was starting to grow on the doormat. I collected it. It's now my pet. And what we see here is a time lapse of how this landscape was changed just over a few minutes. So the moss closes its leaves when the air is dry and hot and opens up quickly when water arrives. It is a mesmerizing process, but it is also very tiny. So normally humans would rarely notice the difference. Here you can see different phases of my doormat pet. The upper image shows how the moss is thriving and even allowing other plants to colonize the rug. The moss kind of prepare a good substrate for other plants as well. But on the bottom you can see it's the same rug on a different day, and part of it was covered, so it did not get any rain. So all the dry area that you can see in the bottom is actually closed moss. It's not dead, it's just in a dormant phase. So mosses grow in colonies of independent strands. We can see these in the left images. The density of the colony supports the individual strands and protects them. And with the simple mechanism of adaptivity, shrinking and closing leaves in response to climate stress mosses can survive long extreme conditions of drought or freeze, and they are able to become dormant for a very long period of time until conditions become better. So for example, scientists just dug up in North UK moss that was frozen for thousands of years, and it revived in the lab under better conditions. And I can tell you from my experience with my doormat, when it stays, it can stay for at least, I can observe it being completely dry for over a month, but then the minute you spray it with water or rain comes, it will become green again. So to make this moss response more visible and detectable for people in real time, I use two technological tools. So one is a computational red filter that emphasizes the dry areas on the mouse rug. So the red color shows the drier areas. And the microlens view to show the movement of the strands. So the moss moves at a relatively fast pace considering other plants. So what you see now is actually real-time response this is hot air, and that's why we hear this sound. So you can see that when hot air is blown, the strands contract and close their leaves, and this is all real time. So the idea that plants move so quickly is uncommon for us. We tend to see plants as a static background, as a landscape, and movement is actually very central to the way we experience our surroundings and how we perceive other beings. So moss can be considered as an interactive matter that may also generate reactions that are more similar to how humans tend to relate or interact with animals, like empathy and care. In the game I created, the moss rug acts as a playing board. Each player gets a territory of moss. Their goal is to keep it the greenest and most prosperous area. During the game, the players get cards and resources, which they use to influence the climate of the moss with water, hot air, and by manipulating the rug's topography as well. As the game progresses, the participants would discover how their actions affect the moss condition. This group started the game under the familiar motivation of competition. Gradually, they developed a sense of care towards the moss, and the players also realized all of their actions affect the whole rug and eventually their own territory. They started to collaborate to try and balance the rug and make sure all areas survive. I did the same workshop with children. We first explored the moss's qualities of adaptation through microscopic lens, and the kids were fascinated to discover this new tiny living creature that they were not really aware of. And they said, it is cooler than a robot. That was a very good feedback for me. The children were more competitive than the adults during the game, so they wanted to win, obviously, but they were also much more emotional and empathetic. They showed concerns about the moss well-being, they warned each other to play cautiously, and they negotiated a fair distribution of resources. The fact that the game involved a living entity impacted dynamics and made the children more aware and careful with their actions and choices. So the moss became a significant visualization tool for the dynamics of the game and a record of how resources were distributed either collaboratively or unevenly. As the group got more competitive, the moss landscape became more destabilized. So how can we further integrate other non-humans and organisms into games we play? Would this kind of integration enhance our understanding or our impact on the environment? And would that encourage more collaboration in games and in reality? And how might the interaction with a living entity and its visualization at a venue, for example, like World Economic Forum, encourage a new approach to our decision-making system, hopefully, and I'm researching that. Thank you.
Is there any question from the audience we can communicate with? Indeed.
Thanks, Nirit. Can you hear us?
Now I can hear you, yeah.
Oh.
We were muted.
Okay. Thank you.
Any question from the audience? I would like to ask something. Do you have any experience that after playing, they took the, you know, the insights they gained from during the game to their own lives? How it relate to the everyday activities?
So yeah, that's a good question. So first of all, what I did realize is that I think anyone that came across with the project or played the game, first of all, they became very aware of mosses, and they started looking at the mosses that grow around them. So that was one thing that went well, because people were quite, you know, they kind of realized, okay, they are living beings, these tiny things that live among us, and maybe they grow. We see it a lot here in the UK. We do have mosses in Israel, by the way. If you look carefully, you will find them in pathways and next to roads. So that was one thing which was good. People were more aware of the things that grow in their environment and weren't just about killing them or removing them from their roof or window. And I don't know if this is if this had a long-term influence, but the conversations were really interesting. And I think this kind of experience should be maybe something more of a long-term process, so that people can actually kind of implement this kind of thinking. So that's something that I'm going to explore further with my research, like how can we make these interactions prevail, you know, kind of spill to our actual way of living. I can tell you that for my experience, it did impact me and my choices in a way. I mean, not completely, but
okay.
I'm trying.
Thank you very, very much, and good luck with your research. Very interesting. Oh, you have a question? Who?
Hi, Nirit. Thank you for the talk. It was very, very interesting. I'm curious about the selection of the planet, of the moss itself, as an ecosystem, and if there was another, like, another ways or another specific planets that you thought about investigating as well.
So can you repeat the question? You are asking why did I choose the moss,
yeah,
or
why
are you
specifically
asking if
moss
there are other
as an ecosystem, and if you had another ideas of another or different plants to use in this research?
Yeah, so, well, it kind of happened accidentally that, I mean, not accidentally, I was becoming aware of the moss that is growing here when I moved to London. And it was, I was very curious about this plant that I didn't really know much about. And I saw it appearing and disappearing, and I started to follow it. And I didn't really realize it will become my MA project and my research object. So I just became very interested in that. But I do know that there are many plants that have a very interesting responsive mechanisms. So I know, I mean, I cannot name them right now because I don't know enough, but I know there are some desert plants, for example, that do really interesting movements and reactions. So these things can surely be explored more.
Okay, we must conclude here. Thank you very much, Nirit, and good luck.
Thank you for having me.